Welcome everybody to another edition of Shape Shorts. The last time Tony Patuca was here talking about space. He's supposed to be back here to talk about, oh, he is right here.
Hi, Stu.
Oh, hi, Tony.
I'm here.
He's going to talk about time, something he's done a lot of research and study on, except on a clock, he can't tell time. But that's okay. We'll leave that. That's not necessary for this lecture. And I want to say to everybody out there, good luck.
Are you staying?
No, are you kidding? I've heard this 100 times.
We brought some more students in, so don't you want to join them, or are you going to take off?
No, I'm going to go get lunch. I'll see you later.
Okay. See you in a bit. And I got a funny feeling you're going to stick around on this one. Well, hello everyone, and thank you so much for joining me today. This is part 2 of our talks about humanities using the Inspirational 6, we call them the I-6. And I'm doing the science part of that where, again, I bring you to a classroom. And in the classroom would be my first day of physics. And as I had talked about this earlier in the previous episode, these only take about we take longer here because I'm emphasizing the I-6 in a video setting, but these only take about 10 minutes to go through the whole thing when you get the students actively involved in understanding the first idea, foundational idea, space. If we're going to really understand the universe, we really have to understand what the universe is, what's it made of, and space is one of the things we take for granted. The second idea I bring up in the classroom is let's now talk about the next commonsensical idea, time. And this is so commonsensical that it defies all form of understanding, because when asked about telling time, as Stu talked to me about I cannot tell time, he didn't ask me what time is. He may ask me what time is it, but when asked about what time is, it's a different question, which has no answer even today. Now, I know those out there listening are going to bring up Einstein and the idea of space-time continuum. We're not going to talk about that. That's a little bit further down the line. My concept in understanding physics to the students and trying to get them to be engaged in what time is to ask them, what is time? And of course, I'll get the same answers. Well, it's the repeating of an event. Well, repeating kind of has the word time in it in a way, repetition. Is temporal in that context. And further discussion about this yields the same kind of problem. Every time I try to define time, I use a word that sounds like time, which means I'm, in essence, not saying anything. I'm just basically, as I used to tell my students, they're just trying to shut me up. That's all they're trying to do. And I'm not going to let that happen. So in effect, let's do one experiment. And let's all out there, including the students that are here, there's 3 of them. Stu's still here. He's in the back. I think he might be awake. I'm not sure. But let's have you do this. I'll do it this way. Stop. And the class would all do that. In general, it would be, in effect, synchronized. You go to a play, you go to a concert, you go to anything that you begin the clapping, it starts out a little bit chaotic, and then within a very short period of time, and again, I can't even make a sentence without using the word time in it, it becomes synchronized like this. Why is that? I mean, shouldn't it be chaotic in a sense? And of course, we'll have all kinds of ideas about that. Maybe it's your heartbeat, it's rhythmic in terms of drums and so on from different cultures and things like that. But the fact is, it's there. And of course, we have other aspects about time. The idea that time is a sequencing of events. Something happens this morning, again, time, this morning, precedes something that happens this afternoon, again, time, afternoon. And we have a kind of a cause and effect issue here. Suddenly, something happens at point A, and then time goes on, and then B occurs. I have breakfast, and then I go to work. I finish work, and then I go home. And the movie is 3 hours. The Netflix series is 45 minutes. All these are commonsensical. No one questions this. But when asked about what you're actually measuring, because that's what it is, you're measuring time, it's the same problem we had with space. I can certainly get a ruler to measure space, and I can use a clock in terms of a hand that has a synchronicity, as if a clapping of the hands, and I have a sensation that it is measuring time. And that measurement of time gets confused with what time is. Now, we won't get into the philosophical foundations because it's extreme, and Stu and I will probably get into more about the ideas that the foundations of space, time, and matter in a different episode. But I wanted to bring into the classroom the idea what students should be questioning is the second foundation of physics. Because as you all know, and it's on our vocabulary today, we all have a temporal aspect. Our day is divided into these temporal parts. Our notion of the idea of motion has time attached to it in our vocabulary. 25 miles per hour, well within your vocabulary. And you know, in 1 hour, you would, in distance, would go over a distance of 25 miles. It's pretty obvious. 50 miles an hour, same idea, 1 hour, 50 miles. So time and space are now commingled into something called velocity, miles per hour. And now we've commingled an undefinable called space with an undefinable called time. And that itself asks the next question for the class would be, does that mean velocity is undefined? Well, in a sense, it is. But in another sense, I can measure velocity in different ways. We'll get into that a little later. But time is probably even more confusing than space. And I only put it in the quantification of more or less, in the sense that time is even more commonsensical than space. Because we all seem to have it. We all seem to have a sensation of time. Sometimes we call this a psychological perspective. You know, at times when you're a child, waiting between your birthdays is forever. When you're older, like Stu Barr gets in his 90s, time, in essence, comes to almost, like every 10 seconds.
Okay, Methuselah.
Every 10 seconds is another year for Stu Barr. So, in effect, we all know the sensation of time. Look at a clock. And, of course, the phrase is, boil the water and look at the clock. Don't do that. Just boil the water. Keep the clock out of it, because the clock slows the water boiling down a little bit. Not so. But the point is, you've got a psychological perspective of time. But we firmly believe that that commonsensical idea is foundational, and in faith alone, everybody senses it the same way. We may disagree about how long it takes for one thing to happen or another, but we all have an agreement that something happened in time. And this becomes very confusing. So, to the students, I want to ask you, how would you define time to a 5-year-old or a 6-year-old in kindergarten, first or second grade? And you know they ask questions. They might not ask questions about space, but they're going to ask questions about time. How do you define it? And this is by no means a new argument. Of course, it has gone on historical. The Greeks didn't have much to do with it at this point. They were more concerned about geometry, space. But later on, in the Middle Ages, in the medieval period, the Christian Middle Church had a great deal to do with time, because it had to do with life after death and so on. Again, the phrase after has a temporal component to it. Augustine would, in that time period, would say the famous phrase, tell me what time is, I can't, but I can tell time. And this has been the fundamental question from day one. Again, Einstein, and you all have heard of Einstein, and I'm sure you've heard of the special theory of relativity and general theory of relativity and black holes and curvature of the universe, all these exotic ideas, and they're beautiful and they're wonderful. But at heart, Einstein did not define time. He defined or redefined how we might measure what we call simultaneity, which is not the same thing as understanding what time is. And our chore in our class today is that my job is to bring it to a point at the end of this course that if I get closer to you understanding and bringing to humanity what time is, then I'm closer to truth than I've ever been. So time becomes a foundational aspect that has no definition at this stage, but yet is foundational. And we're going to use these phrases, space and time, in the next lecture, matter, in these three ideas will constitute what we understand our universe to be consisting of. And none of these three are firmly understood. Thank you.
All right, everybody. We're back after Tony talking about time, which took a lot of time, that most of you will never get back again.
You slept in there all the way, so
no, it went fast for me. That's psychological time. Sleeping, I got rid of you. It was very good. Anyway, we're going to look at some of this, some of the I-6 on there. In Animate, you did a good job with the clapping, and that went to Deus Ex Machina, two of them together.
Yeah.
People, I don't know if anybody's ever noticed, as Tony said, watch an audience clap as a play. It's all chaotic for a minute, and then it turns everybody being the... And why is it? Nope, there's not one going and one going. They all end up the same, whether the audience is 5 or 5,000. Exactly. And it's almost like there is some God in the machine that's telling them, you must clap at the same rate, people. Somebody's out of sync here.
Exactly. So, and it's more than just sound. It's something where it becomes comfortable. You know, you feel as if there's a need for that synchronicity.
Actually, I don't think it's sound at all. It's some psychological reason they happen. And it could be the
psychological time is critical because we live that way. We live in psychological time. Now, we should be clear what psychological time means as opposed to physical time.
Oh, yeah.
And we will get into maybe
that's another subject.
Philosophical foundations.
But until the story, for example, when you said space-time miles per hour, everybody sees that. If there's a 50-mile-an-hour speed limit and you do 70, when you get stopped, next time tell the cop, I don't understand what miles per hour means.
I think you tried that once. I think you tried that once.
I don't know what time means. He said, well, you see the judge, you will. You'll understand that. So, exactly. But it was a good example of telling a story that everybody's done. Everybody does it every day, no matter what you are. You go on the road, you see it everywhere you go. We all have that relationship.
Yeah, and these are very easy, these are kind of easy things to get a hold of because when you talk about commonsensical ideas, particularly in the sciences, we're basing it on the fact that every student out there has that same perception. Yeah. But you go to different cultures, they may have a different concept of the psychological time because we have in our Western culture our idea of partitioned of space. I should say space of the sun at different locations in space. And is this always true historically? I don't think the Greeks had a concept.
No, but what's fascinating about that, though, every culture you go into, as soon as they get a road, a train, an airplane, at kilometers per hour, mile, they all get it the same way.
It's fascinating.
No matter where they're from.
No matter where they're from. So there has to be something there, and we're still engaged in trying to understand what time is, and that's the beauty of physics.
And that's the next one, stimulate.
Stimulate, exactly.
When you tell someone like you, you've spent a lot of time trying to figure out what time is. You have no idea how to tell it. You're the reverse of the population. They know how to tell time.
Right.
You don't care about what time it is.
Exactly.
Because if you don't know what if you can't tell time, why? Because time is ultimately something that for you is very subjective.
Well, think about one thing.
No.
Well, you can only think of, I know you can only think of one thing at a time. I know that. I know that.
What?
The concept that space is linked to time in terms of philosophy, which you said, is interesting in many, many aspects. One of them that is very interesting is that space is multi-directional.
Mhm.
We all can go north, south, east, west, up, down.
Yeah.
So it's got that three-dimensional component. Time only goes forward,
It-
and it starts at a zero. Maybe, of course, today you'll call it a Big Bang, and we all heard of that, whatever that is. We all heard the phrase.
Mhm.
But when you think about it, time it doesn't have dimension. Space does.
Well, it's always fascinated me. If you look at a dimension as a measurement and position of an object, you have to include time.
You do always do. It's
But-
called an event. That is
Yes.
called in
But
more.
the thing that's fascinating to me about it, it's the only dimension I can only move one direction in.
Exactly. And the
Which,
idea,
why is that?
And the idea of moving in time. What is the speed of time? And that becomes now, wait a minute. We
Speed
mentioned
has
it
to be
earlier.
equal to distance.
I said earlier, when you were 90, when you took 90 in a few months, then your time
Not bad.
is
I don't
over-
look too bad for 90, do
Not
I?
too bad, not too bad. But you kind of walk a little bit. Anyway, we're growing. But the point is that time has a different kind of speed, if you will, because you sense time as speed. Oh, the time went by so quickly. If you go for an operation and you have anesthesia,
You know,
you
gone
have,
like that.
it's gone. It suddenly time doesn't exist, and then you wake up an hour later, 40 minutes later, and it's done. And so there's something in the brain, something in our human mind that is gauging time to some extent, but we're missing pieces.
Mhm.
Dimension of space is somewhat clear, at least commonsensically. Dimensions of time
Or not.
are not.
One of the
And that's why I said space is sometimes time is much more convoluted than
Than
space.
space. And it's one of the things we look at for originate time in psychology. How do we really separate our perception of time, as you were just saying,
Right.
psychologically, from any real physical thing of time?
Exactly.
The moment we try to cross that line, what are we perceiving it through? We're perceiving it through our psychology. I don't care whether you're a physicist, a psychologist, a novel writer, whatever. How do I draw that line? And I think when people look at that, there's this assumption that there's this thing called time out there that's a full abstract and real.
Mhm.
And then there's my psychological, which may not be match up. Well, maybe there isn't any real. Maybe the only thing you can perceive time with is that psychology. And I think you brought up a point here. How did we try to get around that in human history? We invented things like clocks.
Right.
So there's some objective measurement so that if I get faster, you brought up something in that thing that I thought was, you get older, time seems to go faster. I thought about that for a long time, and I thought, well, it makes sense that it would go faster because when I'm 10, 5 years is 50% of my life. When I'm 80, 40 years is 50%.
Oh, yeah.
So the percentages change
Percent-
dramatically.
exactly.
So maybe the perception, but clocks were an attempt to try to get around psychological,
Yeah.
particularly for business. I can't run a business.
Kind
in
of put us in lockstep
Yeah.
in that context. And but as part of understanding physics, it's still foundational.
Sure.
And we will, at the end of the next episode, we're going to talk about the three things, the space, time, and matter. We gave up and we just say, okay, we are going to accept A, B, and C. And your common sense is what's going to carry us through.
Well, and that goes to the last
And
thing.
that brings us right to a point where if the foundations are undefined, then we're on a card house.
Well, that goes to the next word, Juvenile.
Yeah.
No one has ever really came up with a good definition of time.
No.
We have no concept of what it is, and yet we use it, as you just said, as a foundation in physics. So it brings up basically a philosophy of science. And I think that kind of brings us to how we, in this episode, applied the I-6 to this. And I see our directors telling us to shut up because you went overtime again.
Yeah, apparently. And also, I think I maybe disturbed the camera. I'm not sure.
Yep, you did.
I probably
You messed
did.
that
I
up.
probably did. Okay.
So if anybody sees something wrong in the camera,
it's all stupid.
don't look at me.
Mhm.
Klutzo did it. Anyway, thanks again, everybody.
Thank you, everybody. Bye bye.